Hello, this is Amos Tarfa, and welcome to our study on the history of math and science in the scientific revolution and the age of enlightenment. We've discussed the importance of a classical Montessori model to learning the history of science and math and the concepts in math and science. And in today's video, what I will be doing is I'll be discussing the first major theme. We've talked about this briefly when I was out in Cambridge. I had a video from I went to Trinity College, Trinity Hall, and Isaac Newton's house in Woolsthorpe, and talked a lot about different aspects of the history of science there. But what we're doing now is we're diving into the course formally and starting with the first major module. We're going to wrestle with science in the 15 and 1600s before Newton's Principia, which came out in 1687. And so we are going to focus on four people in this first part of the course. The scientific revolution, again, we talked about the fact that we had the printing press that came in at the 1450s. So Johannes Gutenberg sort of laid the groundwork for us by giving us a mechanism for the distribution of knowledge. That's great. But then what happens now is that in 1517 we have the Reformation, and that has a place in this discussion, which we'll talk about later on. We have the Reformation, which Martin Luther now has provided an opportunity for more people to have access to the Bible. And if you read the Bible, you hear things like this. Let me read you a few verses. The heavens shall declare his righteousness, Psalm 50 verse 6. Let's read a couple other verses. When I consider thy heavens, the work of thy fingers, the moon and the stars, which thou hast ordained, what is man that thou art mindful of him? So when you read the Bible, and then one more here, behold the height of the stars, how high they are. There's a whole book here called The Stars Speak. It's called Astronomy in the Bible. So just think about the fact that the Bible talks about the heavens. The Bible talks about the vastness of the universe. And more people are thinking about these things now. That's amazing, partly because of the work of the Reformation. And of course, there are other things that led to the Reformation to happen. But let's just go with about 1517, Luther's work that establishes sort of this major event in history. But then in the 1500s also comes a very important figure in the scientific revolution. And that's part of where we're picking it up from today. And that man is Nicholas Copernicus. So we had Johannes Gutenberg, who gave us the printing press. We have the Reformation. We have, of course, the age of exploration that is in action at this point. But then we get the heliocentric view of the solar system. We realize that the sun is the center of the solar system, not the earth, but the sun is the center of the solar system. And so at this point, we've got the groundwork set by Nicholas Copernicus. But the historical context in the 1500s for when he's done this work is very important. There's a religious opposition that he actually would face. He's a monk now, but there's a religious opposition he could face. And then also, there's just the people that thought that the earth was not moving. They thought the earth was steady in one place. Dr. John Lennox, in one of his books, actually starts the discussion about, it's called 7 Days That Divide, and he talks about Galileo and the trial or that discussion about what happened with Galileo. Does the earth move? And Galileo actually carried on this work and also believed in the heliocentric view, and there's some consequences that he faced. But it's just interesting because science doesn't happen in a vacuum. There's a context for which science happens, right? So what you'll notice in the 1500s, again, is that the theological framework affected some of the scientific discussion. But here's the key, though. You can be a Christian and be a scientist all out, no limits. So let's not use the story of Copernicus and Galileo to somehow tell young people that Christianity or faith can hinder their understanding of the world. As a matter of fact, this book, Can Science Explain Everything?, which I'm studying with my students in the STEM Excellence community, it's a wonderful resource that explains the limits of science. And so I just wanted to mention some of that context, that yes, there was the 1500s was a very interesting time theologically. It was also a very interesting time with some wars that are happening, and the 15 and 1600s we have civil wars and just a lot of things happening in the world. But Galileo carries on the tradition. But we just have to pause again and reflect on one individual here who was willing to stand for what he believed. about the universe, and he had evidence for it. There's an explanation that is given in Dr. J. Wiles' book called Science and the Scientific Revolution, where he talks about the Mercury in the sky and just some of the details to understanding the why. There's also a class from Caltech, just a general physics class. I don't believe, there's not a Christian physics class. There's a general physics class, and I just want to give that context, right? I haven't had a chance to watch all 52 lectures, but I've watched a few. Very interesting. They add some of the animation and the details about all of what I'm talking about. But Caltech is one of the best universities in the world when it comes to physics, science, and so on and so forth. And they have a discussion about Kepler and Copernicus and Galileo. So I want to encourage you to check it out. Email amosthemathguy@gmail.com if you want the playlist. But Caltech has that there. And so the reason why that's important is if you want to know the physics, the actual detailed physics of astronomy and, the basics of physics, there are courses out there for you to do that. Part of what this course at this time is going to focus on is on the historical perspective that can then be put side by side with the content that students will learn as we go on. And so we have Galileo, we have Kepler. We'll talk about those two here in a second, but Copernicus has set the stage for us. So now let's turn our attention to two key figures, and then I'll read from our book, The World of Isaac Newton, which has a chapter dedicated to life prior to Newton. Who are these two key figures? The two key figures I wanted to talk about are Galileo and Johannes Kepler. Galileo and Johannes Kepler. So Galileo comes along, and he's a mathematician of a sort. He's an astronomer. He gives us this more of an empirical approach to studying the solar system with a telescope. And part of why this is important is because before Galileo and Copernicus and Kepler, do you realize that we have a huge gap back to people like Pythagoras and Euclid? So it's been like, we're talking over 1,400, 1,500 years. Way more than that. It's been longer than 1,500 years since we had some of the work of some of these geometers that were shaking things like Euclid, right? And so Galileo comes to the scene. He believes in the heliocentric view, and he carries on this work into the 1600s. Galileo did a lot in science, by the way. Falling bodies, and you've heard about the Tower of Pisa. That's all Galileo now, okay? But it's just interesting because Galileo gives us some of this framework then, even the law of inertia. So the thing is, Newton gets a lot of credit for certain things, but we have to look at some of the people that led to this position. But here's the interesting thing we have to give Newton credit for. He says that if I have sinned further, it's because I've stood on the shoulders of giants. And he's, of course, quoting another person from the Middle Ages, John of Salisbury, I believe, something to that effect. It's either a book or an individual. Sorry, I apologize. I should have got that reference handy. It's in my PowerPoint, which I can share with you later. But what is interesting is that Newton acknowledges that he's standing on the shoulders of giants. But who are the giants that Newton is talking about? He's talking about Copernicus, Kepler, and Galileo, amongst others, but at least those three, right? Of course, Descartes, the guy who came up with analytical geometry and the Cartesian plane, we call it, influenced the work of Newton in terms of the groundwork that was laid before Newton came. But that's in the math history, which we'll talk about as well. Notice that math and science, at least we can acknowledge that math and physics have a great relationship together. And so Newton comes along, and he does some amazing work. He's going to be in the series that comes later on. But let's talk about Kepler's contribution. We've talked about Galileo and some of his influence, but let's talk about Kepler. Kepler made it clear that it's not a circular orbit that the planets go, the planets don't go around the sun in a circular orbit. It's an elliptical orbit. And that's very important. And he gave us Kepler's planetary laws. And so what we're going to do is we're going to take Galileo and his contributions, and we're going to dissect them in our next video. We're going to take Kepler and his contributions, and we're going to dissect them in another video. And then we're going to bring in the man who was born on Christmas Day of the year that Galileo died, and that will be Sir Isaac Newton. So I hope that we've kind of seen the role that Copernicus played in bringing us up to this point. Now, let's jump forward and talk about Galileo. Thanks for watching this video. Please feel free to like, share, and subscribe. Share it with others as we continue in our journey in learning science in the scientific revolution. Have a blessed day.